Hi, this is the June 2012 Foundation Tier GCSE Non-Calculator paper, so this is paper 1. In this video we're going to be having a look at all of the solutions to this exam paper. When you're working through this video, it's going to be split into two parts. The first part, I'm going to give you a hint as to how you can go about answering each question. When I've given you a hint, I'd like you to pause the video and then have a go at the question. I'm then going to move on to looking at the answer to the question, so I'll go through the whole answer to the question. So while you're working through these videos, I'd like you to remember to try the questions yourself first, so only use the hint if you need the hint. Work through the answers as you watch, so make sure that you've got a piece of paper or you've got the exam paper in front of you and you're working through it as you're watching. And if there's any time that you feel that you can finish off a question yourself, then pause it and then have a go at finishing off the question yourself. If you need any other help, then you can visit my website, which is www.mathedup.co.uk. There's also my YouTube channel you can subscribe to. There's also a Twitter account, and you can like me on Facebook. Okay, so getting started then, we're going to have a look at question 1. So I'm first of all going to go through a hint. So in this question we're going to write down the numbers that are marked. My hint to you is to first of all decide what gaps there are, what each of these gaps represent. So how much does each of these gaps along here represent? And once you know how much the gaps represent, that will hopefully lead you into knowing what the numbers are going to be. So those are my hints, so if you'd now like to pause the video and have a go. Okay, so the answer to this question then, well, each of these gaps are worth 10. So that here is going to be 310, 320, 330. So when we get to here, this is 350, 360, 370, and that there is going to be 380. So over here I can write my answer, which is going to be 380. Part B says write down the number marked by this arrow. Well, this time, because that's 5 there and that's 6 there, there's 10 bits in between, so this is going to be 0.1 difference each time. So over here we're going to have 6.1, so this here is going to be 6.2. Okay, finally part C says find the number 34 on this number line and mark it with an arrow. So the number 34 is going to be, well, this time the gaps are going to be worth 2 each. So that's 32, 34, 36, 38, 40. So 34 is going to be over there. Okay, and there you go, there's your 3 marks. Okay, question 2, I'll start off by giving you a hint. So we want to measure the line, so you will need a ruler for this. You want to measure this angle here, so you need a protractor for this. And when you're measuring the angle, you need to make sure that you put the centre of your protractor there. So whether you've got a half protractor or a full protractor, you want to put the centre there. And you want to line up the 0 along one of these lines. So if you line the 0 up along this line here, you should then be able to read off the value. Part C says you need to draw accurately a circle of radius 5 centimeters and use the point C as the center of your circle. So the radius is the distance from the middle to the outside of the circle. So decide how you're going to use your compass to draw the circle. Okay, if you'd now like to pause the video and have a go at answering this. Okay, I'm now going to go over the answer to the question. So we're going to start off by measuring this line AB. So if I grab my ruler and I want to put my ruler at one end here, and that's going to be 0, and I can read off here, and my line is actually 5.5 centimeters. I'm going to go with that, 5.5 centimeters. Now on your exam paper this might be slightly different, because it's obviously going to be a different scale. Okay, I'm now going to measure the angle, so I'll leave my ruler there for the time being, and my angle, I'm going to grab my protractor and I get this part of my protractor on the point of the where the two lines intersect each other, which is there, and I can now read off this value here. So there's my line, and I make that, and I'm going this, I'm using the inside here, because I've got 10, 20, 30, and this looks like it's going to be 35 degrees. So I can write that over there, and I'm going to put my answer as 35 degrees. Okay, we don't need that anymore, and over here it says in the space below, draw accurately a circle of radius 5 centimeters. So I'm going to grab my compasses and I'm going to set that to 5 centimeters, open it up 5 centimeters. Now this here is going to give me the radius of my circle that I want to be 5 centimeters. I'm now going to place that there, get rid of my ruler now, and I'm going to draw a circle which is going to have a radius of 5 centimeters. Now again, your circle will look a little bit differently because your scale will be different, but we should have a circle that's going to have a radius of 5 centimeters. Just as a check, you might want to measure from the middle to the outside of the circle to make sure that it's 5 centimeters. Okay, question number 3. So Helen's carried out a survey to find out the fruit her friends like best, and here are her results. We need to complete the table for Helen's results into this table here. We're then going to, so in here we want to tally, and my tip here is maybe do 4 at a time, and then tally it through, and then check at the end to make sure that you've tallied it up correctly, and then write in your frequency. Part B says write down the number of Helen's friends who like bananas best. So you can use your table to decide how many, so the frequency for how many like bananas best. And then part C, you want to draw a suitable chart or diagram to show Helen's results. So think about what kind of diagram is going to best represent the data that you've collected. Is it going to be a bar chart or a line graph or a pie chart? So think about what you think would be the most suitable chart. Okay, those are my hints, so if you'd now like to pause the video and have a go at the question. Okay, I'm now going to go over the answers to this question. So starting with the Italian, we've got apples, bananas, bananas, peaches. So that's apples, bananas, bananas, peaches. Oranges, bananas, oranges, apples. Oranges, bananas, oranges and apples. Peaches, oranges, pineapples, bananas. Peaches, oranges, pineapples and bananas. Bananas, apples, oranges, apples. So bananas, apples, oranges and apples. And then finally pineapples, peaches, bananas, bananas. Pineapples, peaches, bananas, bananas. Okay, what I would do now is I would go through and then just check to see that you've got the right amount of each one, because it would be silly to throw away a mark for just miscounting. So we've got 1, 2, 3, 4 apples, 1, 2, 3, 4, 5, 6, 7, 7 bananas, 1, 2, 3, 4 oranges, 1, 2, 3 peaches, and 1, 2, 2 pineapples. Okay, so I'm happy with that. So we've got 4, 7, 4, 3, and 2. Okay, part B says write down the number of Helen's friends who like bananas best, and we could simply read that off here because bananas is going to be 7. Okay, part C says on the grid draw a suitable chart or diagram to show Helen's results. I think a good chart here would be to do a bar chart, because that will show the frequency clearly. So we could start off by drawing a couple of lines. Let's use green for this. So I will start by drawing a line going up like so, and if we number this, we'll have 0, 2, 4, 6, 8, and I know there's no more than 8, so that's going to be tall enough. And then along here I'm going to have my different bars. So I'm going to have apples, and I draw a bar for apples. That's going to be a bar of 4. A bar for apples, and then we're going to have bananas, which is going to be 7, and I'm going to leave a gap. So my bananas is going to be here, and then we've got oranges, and that's 4, and then we've got peaches, and then we're going to have pineapples. Okay, so peaches is 3 and pineapples is 2. And there we go, there's my bar chart. I might want to just label this here as frequency, and over here this is going to be the fruit. Okay, and there you go. So that was a total of 6 marks for that question. Okay, question 4. Daniel buys 1 loaf of bread costing £1.18, 1 tub of spread costing 94p, and 2 jars of strawberry jam. Daniel pays with a £5 note. He gets 30p change. We want to work out the cost of 1 jar of strawberry jam. Okay, so my hint here is that you might want to have a go at working out how much Daniel spent first of all. So if he's paid with £5 note and you've got 30p change, we can work out how much he spent. We can then work out what the cost of the bread and the spread was, and then we will know how much the two jars of strawberry jam will have cost. We can then, once we've got that information, work out what 1 jar of the strawberry jam costs. Okay, those are my hints, so if you'd now like to pause the video and have a go. Okay, well done if you managed to have a go at that. I'm now going to go over the answer to this. So 1 loaf, so we're going to start off by saying how much money he spent. Well, if he had a £5 note and he got 30p change, we can say, well, that's going to be £5 take away 30p, so that's 30p, and that's going to be £4.70. Okay, so that's how much money he spent. So we now want to know what the cost of the bread and the spread was altogether. So that's going to be £1.18 plus 94p. That's £0.94. And if we add those together, we've got 8 and 4, which makes 12. Carry the 1. 9, 10, 11. Leave my decimal point down here, and I carry the 1, and then I've got 1 and 1, which makes 2, so it's going to be £2.12. Okay, so if he spent £4.70 altogether, and £2.12 of it went on the bread and the spread, we now want to do £4.70 take away £2.12 to work out how much the 2 jars of strawberry jam costed him. So we plus that. So over here now I'm going to do £4.70, and I'm going to take away £2.12. Okay, so doing this subtraction here, 0 take away 2 I can't do, so I'm going to borrow 1 from here, so that's going to become 6. 10 take away 12 is 8. 6 take away 1 is 5. And 4 take away 2 is 2. So that means that he will have £2.58 left. Okay, so 2 jars of strawberry jam must have cost £2.58. So we want to know what 1 jar costs, so I now need to half this number, so I need to do £2.58, and I need to divide that by 2. So you can use a bus stop method if you want here. I'm going to, in fact we'll do the bus stop method, so we'll say 2, 8, so 2's into 2's goes once, I'll put a point there. 2's into 5 goes twice with 1 remainder, so I'll put the 1 remainder there, and 2 into 18 goes 9 times, so that's going to be £1.29. So that's how much 1 jar of strawberry jam is going to cost. That's £1.29. Okay, you might have been able to have done this in your head, because you might have said, well, half of £2 is £1, half of 50 is 25p, and half of 8p is 4p, so 25 and 4 is 29, add the £1 gives you £1.29. Okay, question 5. We want to write down the coordinates of point A, of point B, and then we need to mark the coordinates 3, -4. Okay, my hint for you here is that you need to just remember that you go along the corridor and up the stairs. If you'd now like to pause the video and see if you can have a go at filling these in. Okay, well done if you did that. I'll do this quite quickly. So we've got the coordinates of point A, that's going to be along the corridor 2 and up the stairs 3, so that's going to be 2, 3. We want to then write down the coordinates of point B, that's along the corridor, and this time we're going in this direction, so it's going to be -3, and then we go up the stairs 1, so that's going to be -3, 1. Finally, part B says on the grid mark with a cross the point 3, -4, and label this point C. So we go along the corridor 3 and up the stairs at -4, so that's going to actually be down the stairs, and that takes us there. So that's going to be 3, -4, and I'm going to label that point C. Okay, question number 6. Samina recorded the maximum temperature and the minimum temperature on each of 6 days in January. We first of all want to write down the lowest temperature. We want to work out the difference between the maximum temperature on Wednesday and the minimum temperature on Wednesday, and then work out the minimum temperature on Sunday if we're told that on Sunday it was 5 degrees higher than the minimum temperature on Saturday. Now my hint for you here is that I would first of all draw myself a number line going from 5 to -5. Okay, so if you'd now like to pause the video and have a go at answering this question. Okay, I'm now going to go over the answer to the question. So I said that my tip was to draw yourself a number line, so I'm going to do that first of all, and we are going to write the numbers 5, 4, 3, 2, 1, 0, -1, -2. Okay, right, so on here we want to write down the lowest temperature, but the lowest temperature is obviously going to be at the bottom end of this number line, and I think the lowest temperature here is going to be -5 degrees. Okay, part B says work out the difference between the maximum temperature on Wednesday and the minimum temperature on Wednesday. But if we look on Wednesday, the maximum temperature was 2 degrees, and the minimum temperature on Wednesday was -4 degrees. Okay, so the difference between the two is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it's going to have a difference of 6 degrees centigrade. Okay, the minimum temperature on Sunday was 5 degrees higher than the minimum temperature on Saturday. So the minimum temperature on Saturday was -2, and we want to go 5 degrees higher than that, so we want to add 5 to that. So -2 is over here, -2, and we want to go 5 higher than that, so that's going to be 1, 2, 3, 4, 5, and that takes us to 3, so that's going to be 3 degrees centigrade. Okay, and there you go. Question number 7. So Margaret is going to have a meal. She can choose one starter and one main course. Write down all the possible combinations Margaret can choose. So my hint to you here is that you don't have to write down the whole word. We can just write the first initial of each of the words, because they will start with a different letter. And if you try and be systematic about what you're doing, so if you start with the pate and then see what could match with that, and then move on to the melon, etc. Okay, if you'd now like to pause the video and have a go at writing down all the combinations. Okay, well done if you managed to have a go at that. I'm now going to have a go at this myself. So for starters, we could have had the pate with the beef, the pate with the salmon, and the pate with the lasagna. Or we could have had the melon with the beef, and as you can see I'm being systematic here, the melon and the salmon, and the melon and the lasagna. Or we could have had the ham and the beef, the ham and the salmon, and the ham and the lasagna. Okay. The key to writing down possible combinations is always do it using a method. Don't try to be random about what you're doing. Always follow a pattern and develop a method for doing it. So 2 nice easy marks there. Okay, question 8. Harry asked each student in his class how they travelled to school that day. He used the results to draw this pie chart. How did most of the students travel to school? Well, we know that the bits of the pie are going to represent the number of people, so we're looking for which of those is going to be the biggest. And part B says part B, we're told Harry asked a total of 24 students altogether, so we know that he's asked 24 students. We need to work out the number of students who cycle to school. So if you can use the pie chart to decide what fraction of students cycle to school, that might help. Okay, those are my hints. If you now like to pause the video and have a go at answering the question. I'm now going to go over the full answer to the question. So, how did most of the students travel to school? Well, we can see quite clearly from here the bigger slice of the pie goes to the people that walk, so that will be how most of them travel to school. Okay, we're then told some more information. Harry has asked a total of 24 students, so this whole pie represents 24 students, and we need to work out the number of students who cycle to school. Well, that's going to be this part of the pie here, and we're told that's a right angle, and we should be able to see that that's going to be a quarter of the whole pie. So that means a quarter of 24 students cycle to school. So to work out a quarter of 24, we need to divide 24 by 4. So we can half it and then half it again to divide by 4, or to work out a quarter. So half of 24 is 12, and if I half that again, I get 6. So that's going to be 6 people, 6 students who cycle to school. Okay, question 9. On the grid we need to draw an isosceles triangle. So remember that an isosceles is a triangle that has just two equal sides, which means it also has 2 equal angles. Part B, on the grid we need to draw a rectangle with an area of 12 centimeters squared. So we're going to assume that each of these lines here represents 1 centimeter, and 1 centimeter squared would be one of these squares. So it's the space inside one of these squares is 1 centimeter squared. There we go, so that's 1 centimeter squared. So we need to draw a rectangle that has an area of 12 of these, 12 centimeters squared. Okay, those are my hints. If you'd now like to pause the video and see if you can work out the answers. Okay, I'm now going to go over the answers to these questions. So we need to first of all draw an isosceles triangle, and I'm going to draw myself a nice red isosceles triangle, and my isosceles triangle is going to look like this. In fact, I'll make it a bit longer. There we go. Okay, that might be a possible solution for an isosceles triangle. You might have drawn one a little bit differently. This could be an isosceles triangle. Okay, as long as you've got 2 of the sides the same as each other, then that would be fine. Okay, so that length and that length is the same, so it's an isosceles triangle. Okay, part B says you want to draw a rectangle with an area of 12 centimeters squared. Okay, so we want to have a rectangle that's got 12 squares inside of it. There's a couple of ways we can do this. I'm going to draw my rectangle 2 by 6. 1, 2, 6. Okay, and just as a check there, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 centimeters squared inside that rectangle. You might have drawn a different one. There's lots of different ways you can do this, but we could do a 3 by a 4, and again that's going to have an area of 3, 6, 9, 12 centimeters squared. Okay, so 3 marks for that. Next question. Here is a fair four-sided spinner. Simon is going to spin the spinner once. The spinner will land on 1 or on 2 or 3 or 4. On the probability scale, we need to mark with a letter A the probability that the spinner will land on the number 6. So what are the chances, do you think, of the spinner landing on the number 6? And to remind you, our probability scale goes from 0 to 1, where 0 is impossible and 1 is certain. Part B says on the probability scale, mark with a letter B the probability that the spinner will land on the number 3. So again, you want to think, what chance is there of that happening? There's 4 possible outcomes here, so what chance is it that 3 is going to come up? Okay, those are my hints. So if you'd now like to pause the video and have a go at answering this question. Okay, well done if you managed to have a go at this. I'm going to go through the answers. Well, the probability of getting the number 6, there isn't a number 6 on there, so it's going to be impossible to get the number 6, so the letter A is going to go over here. Part B, the probability scale, mark with the letter B that it will land on the number 3. Well, there's one way of getting a number 3 out of the 4 possible outcomes, so that's going to be a quarter of the way along, so that's a half of the way along, so I think a quarter is going to be about there. Okay, a common error here would be to see the number 3 there and say to yourself that that's going to be 3/4. Okay, so be careful you don't fall into that trap there. It's actually one way of doing it out of 4, and they've all got an equal chance, so it's going to be 1/4, and you can mark your B there. Okay, question 11. Okay, it says write down the value of this here. We've got this little tick sign with a number 81, and I'm going to tell you that tick sign means the square root. So the square root is where we've got a number times by itself that gives us 81. Part B says work out the value of 5 squared plus 2 cubed. So just to remind you that 5 squared means 5 times 5, and 2 cubed means 2 times 2 times 2. Okay, so those are my hints. If you'd now like to pause the video and see if you can have a go at answering the question. Okay, I'm now going to go over the answer to the question. So the square root of 81, a number times by itself that gives us 81, that's going to be the number 9. 9 times 9 gives us 81. For part B, we need to work out 5 squared. Well, 5 squared is 5 times 5, which is 25. Be careful here, a common mistake here is to do 5 times 2, which is 10. And we've got our little index number here, that means that we times our number by itself the number of times we're told to here. So that's 5 times 5. So this one is going to be 2 times 2 times 2. We're being told to times it by itself 3 times here. So 2 times 2 times 2 gives us 8, and then we want to sum those together, so that's going to be 25 plus 8, which gives us 33. Okay, question 12. Amy has some toy bricks. Each brick is a cube of side 1 centimetre. Amy uses some of the bricks to make this solid shape here. Amy adds some more of the bricks to this solid shape to make a cube of side 3 centimetres. We want to know how many bricks Amy adds to this here. So my hint to you here would be to work out, well, how many cubes do I need? How many of these cubes do I need to make a cube that's going to be 3 centimetres long, 3 centimetres wide, and 3 centimetres high? We can then decide how many bricks are here already, and then decide how many more that we need. Naveed uses some of the bricks to make this solid shape, and on the grid we need to draw the view of the solid shape from this direction here. So you need to decide what this is going to look like in 2-dimension if we were looking at it from this direction. Okay, so which parts of the cubes are we going to be able to see? So for example, we'll be able to see that square there. What else will we be able to see? Okay, those are my hints. If you'd now like to pause the video and see if you can have a go at answering the question. Okay, I'm now going to go over the answer to the question. So, for the first part, we're going to need, right, I'm going to show you this cube over here. Okay, so this is a 3x3 cube, and we can see from this that if we just look at this front layer over here, I've got 3, 6, 9 cubes on the front layer, and I've actually got 3 of these layers, so that means I've got 9 and then another 9 in the middle and another 9 at the back, so that's going to be 27 cubes altogether. Okay, so that's how many cubes I'm going to need, and over here, well, we've got 1, 2, 3, 4, 5, 6, and then 1 underneath that one, which is going to be 7. So over here I've got 7 cubes. So in order to make this here, I'm going to need to add another 20 onto this to make it 27. So my answer here is going to be 20. Okay, part B, we need to show what we can see when we look from this direction at this shape. Well, we decided we could see this square here. I could also see this square here, this one here, this one here, and this one up here. And so I'm going to get a U shape in 2-dimension. So we're going to have something that looks like this. Okay, so those 2 squares correspond to this, that one corresponds to that one, and these 2 correspond to these 2 here. Okay, question 13. We've got a timetable over here. So this is our timetable from Birmingham to Leicester. The train leaves Birmingham at 6:35. What time should this train get to Hinckley, and how many minutes should the train take to get to Hinckley? So I'm just going to give you a hint as to how you can go about doing this. So this top row here tells us what time the train leaves Birmingham, and then it arrives at Collis Hill at these times here, and then Nuneaton at these times, etc, etc. And there's actually 1, 2, 3, 4 different trains that we're talking about here. So you can use that information to decide which train this one's talking about and what time that arrives at Hinckley. Okay, Sylvia wants to catch a train to Nuneaton. She needs to get to Leicester before 8:30. So you need to write down the time of the latest train Sylvia can catch from Nuneaton. Well, she needs to get to Leicester before 8:30. You need to decide which train is going to arrive before that time. You could get in a train after that time, and then you need to decide, well, which train would you need to catch in order to get there before that time. We're then told that a train will leave Leicester at 7:27 for Stansted Airport. The train should take 2 hours 28 minutes to go from Leicester to Stansted Airport, and what time should the train get there to Stansted Airport? So we need to decide how we're going to add on this time onto the time that we've got here. So my tip here would be to try adding the hours on first, followed by adding on the minutes. Okay, there's your hints. If you now like to pause the video and see if you can answer the question. Okay, I'm now going to go over the solutions to the question. So if the train leaves at 6:53, it arrives at Hinckley. Well, it's this train here that we're talking about that leaves at 6:53, so it arrives at Hinckley at 7:29. So I need to write the time down as 07:29. And then the second part says, how many minutes should this train take to get to Hinckley? Well, if we start at 6:53 and it takes 7 minutes to get to 7 o'clock, so that's 7 minutes, and then to get to 7:29 it's going to take another 29 minutes. So altogether it takes 7 minutes and 29 minutes, which altogether is 36 minutes. Okay, Sylvia wants to catch a train in Nuneaton. She needs to get to Leicester before 8:30. Well, this train here is going to get there too late. That's going to get there at 8:48, so we want this one here that gets there at 8:17. That's going to get her there on time, and she needs to catch this train from Nuneaton, so that means it's got to be this train here that she catches, which is the 7:51 train. Okay, a train will leave Leicester at 7:27 for Stansted Airport, and the train takes 2 hours 28 minutes to go from Leicester to Stansted Airport. What time should the train get to Stansted Airport? So if it leaves at 7:27 and then it takes 2 hours and 28 minutes, well, I'm going to go 2 hours first of all, so that's going to take me to 9:27. Oops. And then I'm going to go 28 minutes, so let's go 20 minutes first, so 20 minutes, and that's going to be 9:47, and then I can go the final 8 minutes, and 8 minutes for 47 add 8 gives us 55, so that's going to be 9:55. Okay, right, question 14. The diagram shows a rectangle and a square. The perimeter of the rectangle is the same as the perimeter of the square. Work out the length of one side of the square. Okay, so the perimeter is the distance all the way around the shape. So the distance all the way around that shape and that shape, because the perimeter is the same, and the distance around is going to be the same. So that's my hint. If you'd now like to pause the video and see if you can have a go at answering this question. Okay, so let's have a look at this. The perimeter of the rectangle is going to be, well, if that's 2 and that's 8, so that's 10, 12, because those two are going to be the same, and then another 8 because those two are the same, so 12 and 8 makes 20. So we've got 2 plus 8 plus 2 plus 8 equals 20 centimeters. So that means that the perimeter of this is going to be 20 centimeters. Now, because it's a square, each side is going to be the same as each other. So if each side are going to be the same, I need to share this 20 between the 4 sides. So that means I need to do 20 divided by 4, and that's going to give me 5. So each side of this square is going to be 5 centimeters long. So that's 5, 10, 15, 20. There you go. Okay, so 4 marks for that. Question 15. The table shows the minimum distance and maximum distance people should set from different sized TV screens when watching TV. James has a TV with a screen size of 32 inches. He is going to watch his TV. James is going to watch his TV, great. Okay, so part A, what is the minimum distance James should sit from the screen? So if we need to be able to read this table, so this is the size of his TV in inches, and each of these numbers are going to represent the minimum distance corresponding to the size, and then this column here is going to tell us the maximum distance in feet for each of those sizes. So you need to decide which values you need to read off to give you that information there. Now Shiraz has a TV with a screen size of 38 inches. He is going to watch his TV. Work out the difference between the minimum distance and the maximum distance Shiraz should sit from the screen. So decide which bits of information you need from the table and decide how you're going to find the difference between those. Okay, you can use this rule to work out the maximum distance to sit from a TV screen. So we're told the maximum distance in feet is equal to the screen size in inches divided by 4. Claire has a TV with a screen size of 24 inches. So screen size is 24 inches and she is going to watch her TV. And we need to use the rule to work out the maximum distance Claire should sit from her screen. So we know her screen size in inches and we know what the rule is here, so we should be able to work that out. And then Richard should set a maximum distance of 12 feet from his screen. I'm guessing Richard is going to watch his TV, so work out the screen size of Richard's TV. So this time we know what his maximum distance is, so we need to think about how we can use this information to decide what the size of his screen is going to be. Okay, those are my hints to this question. If you'd now like to pause the video and have a go at answering the question. Okay, I'm now going to go over the answers to the question. So first of all, James has got a TV with a size of 32 inches, so there's my 32 inches there. The minimum distance James should sit from the screen, well, this is the minimum distance, and for 32 inches that looks like it's going to be 4 feet. Okay, Shiraz has got a screen size of 38 inches, so this is Shiraz's here, 38 inches. And we need to work out the difference between the minimum distance and the maximum distance that Shiraz should sit from his screen. So the minimum distance is 4.75 and the maximum distance is 9.5. So we need to do 9.5 take away 4.75. Okay, so we can do this by a counting on method. So we've got 4.75. So if we go to 5 first of all, that's going to be 0.25, and then we're going to go to 9, which is another 4, and then finally go to 9.5, which is 0.5. And if we add these together, we've got 4 plus 0.5 is 4.5 plus 0.25, which gives us 4.75 feet. Okay, it's worth being extra careful on calculations like this. What I would do now is I would add 4.75 and 4.75 together and just check that that does actually give you the 9.5 that we've got there. Okay, and then it says you can use this rule to work out the maximum distance to sit from a TV screen. So Claire's TV is 24 inches and we want to work out the maximum distance Claire should sit. Well, if her screen is 24 inches, we can work out the maximum distance by doing 24 divided by 4. So 24 divided by 4, to divide by 4 we can half it and half it again, so half of 24 is 12 and half it again we get 6, so that's going to be 6 feet. Richard should sit a maximum distance of 12 feet from his screen, so this time we know this information here, and we need to work out the screen size of Richard's TV. So if that's 12, we want a number, his screen size in inches, divided by 4, that's going to give us 12. So we can work backwards here, because we're dividing by 4. To work backwards we can times by 4, and 12 times 4, that's going to give me 48. So that means that this Richard screen size is going to be 48 inches. We can check that because 48 divided by 4, that does in fact give us 12, so that's going to be right. Okay, question 16. A quadrilateral has been drawn on the grid. We need to write down the mathematical name of this quadrilateral. Okay, so this quadrilateral has got one set of parallel sides. Okay, so you need to decide which quadrilateral has just one set of parallel sides. Okay, on part B it says on the grid below, show how the quadrilateral tessellates, and we need to draw at least 6 shapes. Now the word tessellates is definitely a word worth remembering. Tessellate, when shapes tessellate, that means that they fit together without any gaps. So you want to decide how you can get some more of these quadrilaterals that are the same as this quadrilateral, so they have to be congruent to each other, the same shape as each other and the same size, that fit together without any gaps. Okay, those are my hints, so if you'd now like to see if you can have a go at answering the question yourself. Okay, I'm now going to go over the answers to the question. So the first shape, this particular shape here with one set of parallel sides, is called a trapezium. That's how you spell the word trapezium. Okay, so we want to see how many of these trapeziums can tessellate. We need to draw 6 of these shapes. I'll use a straight edge for this, green. Okay, so if I rotate this 180 degrees, and I can get another one fitting together like that. Okay, so these two are exactly the same shape as each other. I'll draw another line in there. Okay, so we can see that these two are the same shape as each other, they're congruent to each other, same shape, same size, and then I can whack another one in there, and then I can keep this going. Look, there we go. How about we go underneath like this? How many is that? We got 6 yet? 1, 2, 3, 4. Let's do one more for luck. Okay, and there we go. So that's basically all these shapes tessellating and fit together. I can't resist doing the rest to make it symmetrical. Hey, right. Okay, next one. Question 17. Debbie, Selma, Wendy did a maths test. The total for the test was 40 marks. Debbie got 16 out of 40. Selma got 35% of the 40 marks, and Wendy got 3/8 of the 40 marks. We need to decide who got the highest marks. Okay, so I'm going to start by putting Debbie, and then we'll have Selma over here, and then we'll have Wendy over here. Okay, we're just going to separate them out so that we don't get confused with the working out that we're doing. So my hint to you for this is, well, Debbie got 16, so we need to work out how many marks Selma got. We know she got 35% of 40, but we don't know actually how many marks is that. And also we need to know how many marks Wendy got. We know she got 3/8 of 40. We need to know how many marks that was. Once we know those things, we can decide who got the highest mark. So just a bit more of a hint on these. For this, we can work out what 10% of 40 is, work out what 5% of 40 is, and then decide how we can work out what 35% of 40 is. Yeah, so work out 10% and then 5%, and then we should have enough information to work out 35%. And if you want a bit more of a hint, then for Wendy, we can work out, because we want 3/8 of 40, we can work out 1/8 of 40, and then once I know what 1/8 is, we should be able to work out 3/8 of 40, and then we should be able to compare the marks together. Those are my hints. If you now like to have a go at pausing the video and then finishing off this question. Okay, well done if you managed to have a go at that. So we already knew Debbie had 16, Salma, well 10% of 40 is 4, 5% of 40 is 2, 35% of 40, well that's going to be 3 lots of this, that's going to give me 30%, so 3 lots of 4 is 12, and then we need to add the 2 to get 35%, so that's going to be 14. Yes, so 3 lots of 10 is 30%, and 5 makes 35%, 3 lots of 4 is 12, and 2 makes 14. For Wendy's mark, well Wendy got 3/8 of the 40 mark, so 1/8 of 40. To work that out, we need to do 40 divided by 8, and that gives us 5. And then 3/8 of 40, well if 1/8 is 5, then 3/8 is going to be 3 lots of 5, which is 15. So Selma got 14, Wendy got 15, Debbie got 16, the highest mark. We can say Debbie got the highest mark. Okay, there you go. And just to highlight, that's got an asterisk next to it, which means that it was important that we communicated our work clearly, which we've done. Okay, question 18. Again, we've got an asterisk next to the 18, so we need to make sure we're communicating our work clearly. Bill uses his van to deliver parcels. For each parcel Bill delivers, there is a fixed charge plus £1 for each mile. You can use a graph to find the total cost of having a parcel delivered by Bill. We need to know first of all how much the fixed charge is. So when they haven't travelled at all, is there a charge that exists? And if there is, that's going to be the fixed charge. Yeah. Okay, so decide how you're going to work that out from this graph. Ed uses the van to deliver parcels. For each parcel Ed delivers, it costs £1.50 for each mile. There is no fixed charge. We need to compare the cost of having a parcel delivered by Bill with the cost of having a parcel delivered by Ed. So a useful way of doing this would be to, or an easy way of doing this would be to see if you can put this information onto this graph here. You should then be able to clearly compare the two things together. Okay, those are my hints. If you'd now like to pause the video and see if you can answer the question for yourself. Okay, I'm now going to go over the answers to the questions. So the fixed charge here, well this is how much he gets charged before he's travelled any miles. So after he's travelled 0 miles, he gets charged this £10 here. So our fixed charge is going to be £10. Okay. Right, so it looks like there's a £10 charge, and then after every mile he gets an extra £1 charged. So that's why after 10 miles he's paying £20, after 20 miles he's paying £30, etc. Okay, Ed uses a van to deliver parcels. For each parcel Ed delivers, it costs £1.50 for each mile, and there's no fixed charge, and we need to compare that together. So I'm going to draw a line on this graph that represents this. So we'll do a red line, and I'll use a thin line so we can read off clearly. Now there's no fixed charge, so this time not travelling at all is not going to cost any money, and it's £1.50 for each mile. Now it's going to be difficult to mark £1.50 for each mile, so what we might want to do is work out what it would be for 10 miles. So for 10 miles it's going to be £15, which is going to be there. And for 20 miles it's going to be, well, for 10 miles it's £15, 20 miles it's going to be £30, and that's going to be there, and etc. So for 30 miles it's going to be £45, that's 40, 45 there, and then I've got enough points there to draw my line in. Right, so starting over here, we're going to have a line that goes through all of those points. May have messed it up a little bit. There we go. Right, okay, so that's almost done now. What we now need to do is make sure that we're explaining what's happened. So looking at the graph, it looks like it's cheaper to use Ed to deliver your parcels when you're travelling 5 miles or 10 miles, because we can see that the cost is going to be less even at 15 miles. But as we increase, once we get to 20 miles, it seems to cross over, because all of a sudden Ed seems to be more expensive. So paying £1.50 for each mile, that's going to start costing more than paying the fixed charge. So what we can say is that Ed is cheaper up to, and it's up to 20 miles. Okay, so up to 20 miles. And then it seems that after 20 miles, all of a sudden Bill is cheaper. So we could say after 20 miles our mate Bill is going to be cheaper. Okay, and there you go, that's enough information. So we've represented this on the graph, and we've compared the two things together. Okay, question 19. We've got a pack of 9 toilet rolls costs £4.23, and a pack of 4 toilet rolls costs £1.96. We need to decide which pack gives the better value for money, and we need to show all of our working out. Now my hint here, I guess, is that it's difficult to compare 9 with 4 at the moment. So what we might want to do is work out what a single toilet roll would cost if I bought a pack of 9, and how much a single toilet roll would cost if I bought a pack of 4. I could then compare those together and decide which gives me the better value for money. Okay, so that's my hint. If you'd now like to pause the video and see if you can have a go at working it out for yourself. Okay, I wonder if you managed to have a go at that. I'm now going to go over the answer to this. There's actually a couple of ways of doing this, so I'm going to do it I'll do it in 2 different ways. So the first way we can do this is work out how much one roll would cost if I bought a pack of 9. So so if we start by saying pack of 9 here. Okay, so for my pack of 9, I'm going to work out what one roll costs. So I'm going to do 9 into £4.23. So we can use our bus stop method again. Okay, 9s into 4s we can't do, so I'm going to put a 0 there, and my decimal point needs to line up, and I'm going to carry that 4 over here. 9s into 42, well, that's going to be 4. That's 4 9s are 36, and we'll have 6 left over here, and then we can do 9s into 63, which is going to be 7. Okay, so for the pack of 9, one roll costs 47p. One roll costs 47p. Okay, and now I'm going to have a look at the pack of 4. Okay, so this time we're going to see how many 4s go into £1.96. So 4s into 1, 0 there and a point, and carry the 1. 4s into 19s, that's going to be 4 remainder 3, and 4s into 36 is going to be 9. So with my pack of 4, one roll costs, and that's going to be 49p. Okay, and we can see clearly now that 47p for a roll is going to be cheaper than 49p for a roll, so actually that's going to be cheaper, so my pack of 9 is going to be cheaper. So right, okay, so that's how we can work it out. Now another way we could have done this is I can come over here and we'll say pack of 9 and we'll do pack of 4. Okay, so instead of working out what it was for one roll, I can see if I can get a common multiple of 9 and 4. So a number that's in the 9 times table and the 4 times table. Okay, and you might spot the number 36 is in your 9 times table and your 4 times table. So I can start by saying I want to work out 36 rolls for that one, and I'm going to work out 36 rolls for this one. Okay, so if 9 rolls cost £4.23, then 36 rolls, well that's going to be 4 times as much. That's going to be 4 packs of this, so I need to times this number by 4 as well. So I'm going to do £4.23 times by 4. I'm not going to go through the full working of this, but that works out to be £16. 4 4s are 16. That's going to be 80, so that's going to be £16.92. And then similarly over here, if I've got a pack of 4 and I want to know what 36 rolls are, I need to buy 9 packs of 4, so I need to do, well, 4 rolls are going to cost £1.96. So 36 rolls, that's going to be 9 packs of 4. I want to do 9 times £1.96, and again I'm not going to go through the full working of this. That works out to be £17.64. And again we can see that the pack of 9 is going to be cheaper. The reason why I showed you both ways is that you might prefer to do a multiplication method rather than a division method. Okay, so there's 2 ways of going about it. Okay, question 20. The stem and leaf diagram shows some information about the speed of 25 cars. How many of the 25 cars had a speed of more than 50 miles per hour? Okay, so we've got a key here, and the 2 and the 9 means that that's 29 miles per hour. So we want to see if we can interpret how many of the cars had a speed of more than 50 miles per hour. So just to give you an idea of how we can read this, this number here represents 38 miles per hour. This number here represents 43 miles per hour, and you need to decide how many of the 25 cars had a speed of more than 50 miles per hour. Okay, and Part B says find the median speed. So if I lined all of these up, the median is going to be the middle speed. And part C says work out the range of the speeds. That's how spread out our speeds are, and that's going to be our largest take away our smallest to work out the range. Okay, those are my hints. See if you can now pause the video and have a go at answering the question. Okay, well done if you managed to have a go. We'll have a quick look at this now. So how many of the 25 cars at a speed more than 50 miles per hour? Well, that's 49 miles per hour. This is 51, so that's more than 50, so that's 1, 52, 54, 55, 56 and 60. So we've got 1, 2, 3, 4, 5, 6. So 6 cars have a speed that is more than 50 miles per hour. Okay, part B says find the median speed. A couple of ways of doing this. I'm going to chop into it. So if I chop into by doing my largest and then my smallest each time, so that's going to be, cross out those two, so that's the largest is 60, the smallest 29, and then the next largest is 56, the next smallest is 31, and then I keep going. Keep slicing in, so 51, 37, and then 49, 38, 49, 38, 48, 39, and I'm doing this in pairs because I need to be careful that I don't do too many on one side. And there you go. So I've got one number in the middle, so my median is actually going to be 44 miles per hour. Okay, part C says work out the range of the speeds. So that's going to be the difference between the largest and the smallest, where the largest is 60 and the smallest is 29. So when we do 60 take away 29, and that's going to be 31 miles per hour. Okay, question 21. ABC is a straight line, BD is equal to CD. There's dashes here that tell us that they're the same length. Angle BDC is 50 degrees, so B to D to C, that angle there is 50 degrees, and ADB is 20 degrees, A to D to B, that angle there is 20 degrees. We need to work out the size of the angle marked X, this angle here, and we need to give reasons for our answer. Okay, so my hint here is that you may not be able to work out this angle directly. So I would have a go at working out all of the angles that you can, and think about how you're working them out and what angle rules you're using to work them out, and then see if you can finally end up at working this angle out. Okay, so you might want to start with these angles here. Okay, before you pause the video, I want you to notice that there's an asterisk here, which means that you need to communicate your work clearly, because the quality of your written work will be assessed. Okay, if you like, pause the video and have a go. Okay, I'm now going to go over the answers to this question here. So I'm going to start off by working out this angle here. Because this is an isosceles triangle, I can do 180 take away 50, which will tell me that there's 130 degrees left that need to be shared between these two angles here. So I'm going to say that this is an isosceles triangle. So I should say BDC. BDC is an isosceles triangle. So two base angles are the same. Okay, so that means I can do 180 take away 50, which gives me 130, and then I can do 130 divided by 2, and that gives me 65 degrees. Okay, so that's going to be 65 degrees, and that's going to be 65 degrees. Okay, so and then we can say angles on a straight line add up to 180, so if that's 65, we can work out that angle there. So angles on a straight line add to 180 degrees. So we can do 180 degrees take away 65 degrees, and that's going to give us 115 degrees. Okay, and then for the last part we can say, well, angles and the angles in a triangle add up to 180. Okay, so the angles in a triangle add to 180 degrees, so therefore I can do 180 take away 115, take away 20, and that's going to be 180 take away 15, sorry, 115 is going to be 65 degrees, take away 20 is going to give me 45 degrees. Okay, so that here is going to be 45 degrees. So we can say x is going to be equal to 45 degrees, and I'll just put a box around that so we can see my answer clearly. Okay, and there you go, there's our answer for 4 marks. Now we need to make sure that at each stage we're given the reasons for our answers. Okay, question 22. The diagram shows a patio in the shape of a rectangle. The patio is 3.6 meters long and 3 meters wide. Matthew is going to cover the patio with paving slabs. Each paving slab is a square of 60 centimeters. Matthew buys 32 of the paving slabs. So for part A, we need to decide whether Matthew has bought enough paving slabs to cover the whole patio, and we need to show our working out. So if each paving slab is 60 centimeters, I want you to think how many you could fit along here, and then how many you can fit up here, and how does that tell you how many fit in the whole rectangle, and then decide whether he's bought enough. The paving slabs cost £8.63 each. You need to work out the total cost of the 32 paving slabs. So we need to do a multiplication to work this out. So you can either use a grid method here, or you can use a column method if you prefer, or another method. So you can decide how you're going to go about doing that. Anyway, those are my hints, so if you'd now like to pause the video and see if you can have a go at answering the question. Okay, I'm now going to go over the full answer to this question. So starting with part A, Matthew is going to cover the patio with paving slabs that are 60 centimeters long. Well, if they're 60 centimeters long, and this is 3.6 meters, so that's going to be 360 centimeters. and I want to know how many 60 centimeters are going to fit along here. So I need to do 360, and I need to divide that by 60 to see how many are going to fit along here. And 360 divided by 60, sorry, 360 divided by 60 is going to be the same as 36 divided by 6, which is going to be 6. So that means 6 of the paving slabs are going to fit along here. Okay, so we're going to have something that looks like 1, 2, 3, 4, 5, 6. Okay, I've not drawn this to scale obviously yet, but I'm just trying to highlight that there's going to be 6 slabs of 60 centimeters in length that are going to fit along here. Okay, I've then got 3 meters up, so that's going to be 300 centimeters. So I want to know how many of these 60 centimeter slabs fit high. So we do 300 divided by 60, and that's going to tell me that there's actually going to be 5 slabs that fit up here. So we've got 1, 2, 3, 4, 5 high. Okay, so we've got 1, 2, 3, 4, 5 high and 6 wide. Okay, so that means I'm going to have 5 and then another 5 down here, 10, 15, 20, 25, 30. And I'm just going to highlight what this actually looks like. So this is what it's going to look like. It's 6 slabs across, 1, 2, 3, 4, 5, 6, and 5 slabs up, 1, 2, 3, 4, 5. And each of the slabs is going to be 60 centimeters by 60 centimeters. Now you don't need to draw this on your diagram. I'm just doing it to highlight what's going on. So I've now got 5, 10, 15, 20, 25, 30 slabs that I need. So I can show that in my calculation by saying 5 times 6 is equal to 30. Okay, so Matthew buys 32 slabs, he needs 30, so Matthew needs 30 slabs, so we can say he buys enough. He buys enough. Okay, and then the paving slabs cost £8.63 each, and we need to work out the total cost of the 32 paving slabs. So we need to do 32 times by £8.63. Now you can use any method that you want for this. I'm just going to come and work over here because I've not left myself enough room. I'm going to use the grid method, so I'm going to partition this into 30 and 2, and then £8.63 I'm going to write that as 863p, so 863. Okay, and try and be neat. Right, so we've got 30 times 80, so we've got 3 times 8, which is 24, and then we need to times it by another 10 and times it by another 100. That's going to be another 1,000, so that's going to give us another 3 zeros. So that's 24,000. Now it's worth double checking this because this is the bit that most people will often make an error on. So just double check that this part of the calculation is correct. 30 times 60, well 3 times 6 is 18, and we need to times it by 10 and times it by another 10, so that's timesing it by 100, so that's 1,800. 30 times 3 is 90, 2 times 800 is 1600, 2 times 60 is 120, and 2 times 3 is 6. Now I would double check and triple check all of the numbers that are in here, because you don't want to get any of these numbers wrong, because the whole thing will then fall apart. So we can then add these together. So we've got, if we do a row at a time, that usually makes it a little bit easier. So going along here, we've got 24,000 and 1,800, which is 25,800, and then 90, so 25,890, and then we've got 1,600 and 120, so that's 1,720 and 6, so 1,726. We can then add those together. 0 and 6 makes 6, 9 and 2 makes 11, carry the 1, 8 and 7 is 15, and 1 is 16, 5 and 1 and 1 is 7, and then we've got our 2, so that's going to be 27,616. Now this is in pence, we want our answer in pounds, so I need to, in order to convert this back into pounds, I need to divide it by 100. So that means I get 276 pounds and 16 pence. Okay, now a good idea here is to just double check and to see whether that sounds reasonable. So this here is roughly £9, and this here is roughly 30, and 9 times 30, well 9 times 3 is 27, so 9 times 30 is going to be 270, and we can see that that's roughly £270. So it sounds like we've got the right kind of number here. Okay. Question 23. So here are the ingredients needed to make 12 shortcakes. Liz makes some shortcakes. She uses 25 milliliters of milk. How many shortcakes does Liz make? So in this recipe there's 10 milliliters of milk, and Liz uses 25 milliliters of milk. So how many times more has she used? Okay, and Robert has this set of ingredients here, and we need to work out the greatest number of shortcakes Robert can make. So we need to decide what he would run out of. So he might be able to make 10 times of this recipe based on his sugar, but then that might mean that he runs out of butter or runs out of flour. So you need to decide what's the greatest number of shortcakes he can make without running out of any ingredients. Okay, those are my hints, so if you now like to pause the video and see if you can have a go at answering the question. Okay, well done if you managed to have a go at that. I'm now going to go over the answers to the questions. So Liz makes some shortcakes. She uses 25 milliliters of milk. In this recipe she's used 10 milliliters of milk to make 12 shortcakes. So that looks like there's going to be 2.5 times as many. So we're going to have 2.5 times as many shortcakes. So 2.5 lots of 12, or 2 lots of 12 is 24, and half of 12 is 6. So 24 and 6 makes 30. So that's one way that we can do it. We can say we want to do 12 times 2.5, and that gives us 30. Another way that we can do this, and a lot of people will find this easier, is scale this down first to 5 milliliters of milk. So if she had 5 milliliters of milk, that would be 6 shortcakes. So if 5 milliliters is 6, this is obviously 5 times as much as that, so it's going to be 5 times as much as 6. So we can do 5 times 6, and that gives us 30. So either way we can get the answer of 30. Okay, for part B, we're given this recipe, we're given this set of ingredients here, and we need to work out the greatest number of shortcakes Robert can make. So based on the sugar, he should be able to make 10 lots of this, which is 120 shortcakes. Based on the butter, well, he can make 5 lots of this, so that's going to be 5 times 12, which is 60. And then based on the flour, I said shower, based on the flour, that's going to be 5 times 12 again. Yeah, because you can make this recipe 5 times with 1,000 grams of flour. 5 times 12, which is 60 again. And then he's got 500 milliliters of milk. Well, he can make this 50 times with that much milk. So we could do 50 times 12, which is equal to 600. Okay, so now we don't really need to highlight all of this, but we should be able to see, well, he's got plenty of milk, so he's not going to run out of milk, but he has got a limited amount of butter and flour, and actually the greatest number of shortbreads he can make, well, he can't make 120 because it will run out of butter and flour, so it's going to be 60. There you go. Okay, so if you make 60, he's not going to run out of sugar or butter or flour or milk. Okay, and there's your answer. Okay, question 24. Buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton both leave the bus station at 9 AM. And we want to know when a bus to Acton and a bus to Barton next leave the bus station at the same time. So the bus to Acton is going to leave after 24 minutes, and then again after 48 minutes, and then again after 72 minutes, etc, etc. And this one's going to leave after 20 minutes, and then 40 minutes, and then 60 minutes, and then 80 minutes, etc, etc. So we're looking for a common multiple of 24 and 20, and that will tell us when they'll both leave the bus station again at the next time. So that's my hint. See if you'd now like to pause the video and see if you can have a go at answering the question. Okay, there's a few ways of doing this, and some of you may be able to spot the common multiple fairly quickly. I'm just going to go ahead and I'm going to list some multiples of 24 and 20. So I'm going to list the multiples of 24 first. So that's going to be 24, 48, 72, 96, 120, 144, etc. I'm now going to list the multiples of 20, and I'm going to try and find to see where I'm going to get a number that's the same in both lists. So we've got 20, 40, 60, 80, 100 and 120, and we've spotted now that I've got 120 here and 120 here. So that means that it's going to take 120 minutes, which is the same as well, 60 minutes in an hour, so that's going to be 2 hours before the buses leave again at the same time. So if it was 9 AM before, it's now going to be 2 hours later, which is going to be 11 AM. I've done 9 add 2, that gives me 11 to get my 11 AM. Okay, question 25. This time we've got a little bit of algebra to do, so we need to expand 3 times, and in brackets we've got 2y take away 5, and then we want to factorize this completely, and then we want to make h the subject of this formula. Okay, so I'm just going to draw on some hints for you here. So we're going to do expand the brackets, and the factorize, that's going to be the opposite of expanding, so we want to put the brackets back in for this. So think about how you're going to do that. Think about the common factors. And part C, we want to make h the subject of the formula. Okay, so just get started. Okay, and if we draw some lines either side of this, okay, and we want to decide what I need to do to each side of this formula in order to end up with h is equal to something. Okay, those are my hints, so if you'd now like to pause the video and see if you can have a go at answering those questions. Okay, I'm now going to go over the answer to this question. So 3 lots of 2y take away 5. Well, let's just think about what that means. That means 2y take away 5. We've got it 3 times, so we've got another 2y take away 5, another 2y take away 5. So altogether we've got 6y, and we've got to take away 15. So it's going to be 6y take away 15. And using this method here, we've got 3 times 2y, which is the 6y bit, and 3 times take away 5, which gives us the take away 15 bit. Part B says factorize completely. So this time we've got an expression that we want to put back into brackets. Now we're looking for a common factor of 8x squared and 4x. So we might spot that 4 is a common factor of 8 and 4, so we've got 4 straight away. And also x is a common factor of x squared and x, so we've got an x over here. And now I open my brackets and I decide, what do I times 4x by to give me 8x squared? Well, I need to do 4 times 2 to get the 8, and I need to times x by x to get the x squared. So 4x times 2x gives us 8x squared. We've got a plus here, and then I've got well, what do I times 4x by to give me 4xy? And that's going to be y. So we've got 4x times by y, that gives me the 4xy. So this has now been fully factorized. My answer will be 4x times by 2x plus y. Okay, for part C it says make h the subject of this formula. So I've got t is equal to g times h divided by 10. So I'm going to start off by multiplying both sides of this formula by 10. So times 10 there, times 10 there. So that means this here is going to become 10t, and this here is going to be equal to just gh. Okay, remember I'm making h the subject, so I need to undo this g here, so we want to divide both sides by g. So dividing this side by g, I've got 10t divided by g, and divide this side by g, and that's going to just leave me with h. So I can say that h is equal to 10t divided by g. And there we go. Okay, question 20. There are 300 milliliters of medicine in a bottle. Mary has to take 2 5 milliliter spoons full of medicine twice a day. Mary has to take the medicine until the bottle is empty. How many days did Mary have to take the medicine for? Okay, so my hint here is, well, if she had to take 2 5 milliliter spoonfuls, how much is that? And she needs to take that twice a day, so how much is that? So how much before she runs out of medicine? How many days is it going to be until she runs out of medicine? Okay, the next part says you can work out the amount of medicine to give to a child by using this formula here. M is the age of the child in months. A is the adult dose in milliliters. A child is 30 months old. An adult's dose is 40 milliliters. We need to work out the amount of medicine you can give to a child. So we know what M is and we know what A is, so we should be able to use this formula to work out what C is. Okay, so those are my hints. So if you'd now like to pause the video, and I'll just drop it down here and see if you can work out the answer to this question. Okay, I'm now going to go over the answers to this question. Okay, so first of all, Mary has to take 2 5ml spoonful of medicine, so that's 2 times 5, which is 10 milliliters of medicine twice a day. So we need to do 10 milliliters twice a day, so we've got 10 times 2, which gives us 20 milliliters. So she takes 20 milliliters per day. So if she's got 300 milliliters of medicine and she's having 20 milliliters per day, so after 2 days she'll have had 40 and then 60 and then 80. So we need to work out how many days until she runs out of medicine. So the calculation we can do here is we can see, well, how many 20s are going to go into 300. Okay, so well, 300 divided by 20 is going to be the same as 30 divided by 2, which is 15. So it's going to take her 15 days before she runs out of medicine. Okay, the next part of the question says we can work out the medicine using this formula here. M is the age of the child in months, and a child is 30 months old, so that means that M is going to be equal to 30. A is an adult dose in milliliters, and it says an adult's dose is 40 milliliters, so A is going to be equal to 40. And we need to work out the amount of medicine you can give to a child. Well, MA means 30 times 40, so that means C is going to be equal to 30 times 40, which is M times A, divided by 150. Okay, so 30 times 40, well, 3 times 4 is 12, and then we need to times that by 10 and times by 10 again, so that's times by 100, so that's going to give me 1200, and we need to divide that by 150. Okay, 1200 divided by 150, well, that's going to be the same as, and we can cancel that, so we're going to have 120 divided by 15, and we can simplify that further because 120 divided by 15, well, that's going to be 8. Okay, so that means that we can give 8 milliliters to a child. So the answer here is going to be 8. Okay. Question 27. Okay, so we are given this diagram here that's a parallelogram. The size of the angles are in degrees, and we need to work out the value of x. Now, in a parallelogram, we know that the opposite angles are going to be equal to each other. So we can see over here that 2x and 2x are the same as each other, and we can see here that this here and this here is going to be the same as each other. So we should be able to come up with an equation based on that, and we should be able to solve that equation. There's actually another way of doing it, because we know that all of these angles, well, this is a quadrilateral, and we know the angles in a quadrilateral add up to a certain number, so we know all of these have to add up to this certain number, so we can set up an equation based on that as well. Okay, those are my hints, but you can now use one of those methods and see if you can solve this question. Okay, I'm now going to go over the answer to this question. So we'll use this method first, where we're saying this angle and this angle are the same as each other. So that means that 3x take away 15 is going to be equal to 2x plus 24. Okay, so draw lines either side here. Okay, so in order to solve this equation, well, first of all, I'm going to add 15 to both sides, because we want to get rid of that take away 15. So if I add 15 here, I also need to add 15 here. So this here is going to become 3x, and this here is going to become, well, if I add 15, I'll have 2x plus 39. Okay, I'm now going to subtract 2x from both sides. So this here becomes x, subtract 2x, and this here becomes, if I subtract 2x, I've just got 39. So my answer here is going to be x is equal to 39. Okay, I can actually do this in a different way as well. So we're going to have a look at this other method, and that's spotting that all of these angles add up to 360 degrees. So that means 3x take away 15 plus 2x plus 2x plus 24 plus 2x, all of those add up to 360 degrees. Now I'm going to simplify this first, because I've got 3x and 2x and 2x and 2x, so altogether that's going to be 2, 4, 6, 9x. And I've got a take away 15 here and a plus 24 here, so altogether that's going to be plus 9. And that's equal to 360. Okay, and again, if I draw my bars either side here, and I'm going to start by, well, I want to ditch that 9, so I'm going to subtract 9 from both sides. That's going to be 9x equals, and that's 351. I then need to divide both sides by 9, and so if I divide by 9, I divide by 9, and that actually does work out to be x is equal to 39, and we've got the same answer there again. Okay, so either of these methods you can use, and we can see that both of them come up with the same answer. Okay, thanks very much for watching. Hopefully you found that useful, and I look forward to seeing you again soon. Take care.